Hello, and welcome to the session on how to diagnose Oracle database upgrade issues. My name is Roy Swonger, and I'm Vice President for Database Upgrade, Utilities, and Patching at Oracle. And that means that my groups are responsible for creating the database upgrade scripts. Auto Upgrade is our most recent creation. Also, utilities like Data Pump, SQL Loader, Transportable Table Spaces, the Metadata API. And we are now also responsible for Data Patch, the utility that applies SQL changes to the database after you've used OPatch to patch your Oracle home. So we're going to talk about four general areas during this session. The first, and a very important one, is why upgrade is different when it comes to diagnosing issues compared to other types of database issues that you may be called on to diagnose as a DBA or a developer. And the first thing that you'll notice if you really delve into what the upgrade is and what it does is that upgrade is not like your typical OLTP or data warehousing workload. It's really heavy on DDL, which you can see the catalog of statements in a typical upgrade here. This was from 12.2, where we kind of looked at what was in the upgrade logs and what are the actions that are performed as part of a database upgrade. And you'll see there's a lot of altering of objects, alter type, alter table, and so on, a lot of creating and replacing. And that comes in when we're updating the PL SQL packages in the database or views, for example. We're doing a lot of grants, and we may be revoking things too as well for security purposes. And then we're creating other metadata objects, tables, indexes, constraints, triggers, and so on. All of that is happening in your data dictionary, and that is mostly confined to the system table spaces, system, sysocs, and then other related table spaces for particular components like MDSys for spatial, for example. Those system table spaces have their own unique qualities. For example, they cannot have ASSM, Automatic Segment Space Management, enabled, at least not just yet. So all of that makes upgrade different just on its face. But there are some other things that make it a bit more complicated to diagnose upgrade issues. The first of them is upgrade mode. When you want to upgrade your database, you're going to start in upgrade mode. And if you weren't aware of exactly what that does, at a high level, it gives us exclusive access to the database, because the kind of things we are going to do, creating and replacing PL SQL packages at the very foundation of your application, or changing the topology of a dictionary table, which will cause cascading invalidations for anybody who uses it, even views defined on that table. Those kind of things would be very disruptive to any application. And also there could be deadlock issues if someone was using one of those objects when we went to replace it. So we get exclusive access to the database. And that means that, first of all, you need sysdba privilege to modify a lot of these objects. Second is there are times when we kind of expect errors to happen because, for example, the database upgrade is rerunnable. And if you rerun that database upgrade, some of these objects you go to create will already have been created, and we will expect that object already exists error. So we filter those out during the upgrade. But then that enforcement of exclusive access to the database means that anything that causes background processing is going to be disabled. That means everything from system triggers. There are some triggers, for example, that fire whenever you issue a DDL statement. And you can imagine how disruptive that would be with all the DDL that upgrade is doing. We disable advanced queuing, the job scheduler, and the job scheduler also includes any of your background jobs, stats gathering, AWR reporting, and so on. And AWR itself is not available during the upgrade because the packages that implement a lot of its functions, and even the views and tables on which it's defined, are going to be changing as part of the upgrade. So that takes away one of those tools that you would normally use to diagnose issues. So you see here a screenshot of what happens in your alert log, or part of the alert log, when you just say startup upgrade. And you can see some of the things that get disabled, but it gives you a sense of how different this environment is compared to your runtime environment in production. Another area that is very different for upgrade is when it comes to multi-tenant. because upgrading a PDB can happen when the CDB root is open in normal mode. So that does give us just a little bit of benefit when it comes to diagnosing issues in a PDB upgrade. Because while you cannot get the per PDB AWR information, for example, you do have the diagnostics repository running at the CDB wide level. So you can get things like instance resource utilization metrics, for example, and maybe some high-level weight events, because remember, in a multi-tenant environment, you have one set of background processes running all of your pluggable databases. So those background processes are still being measured by the container-wide automatic workload repository. A third area where things are a little different for upgrade is the set of factors that will affect performance of your upgrade. While you think in OLTP terms about how many concurrent users you have, for example, well, in upgrade, we only have one. If you think in data warehousing terms, you might think about just how big your tables are and how much the volume of data you have to sift through with a query might be. All of that's irrelevant for database, for upgrade performance. Now, the things that do matter for your upgrade are not going to be things that matter for OLTP. So that's the flip side of the coin, where the most important thing is how many components do you have installed in your database. Every single component, spatial, Java, XML database, and so on, every one of those has an upgrade script that runs as part of the overall database upgrade. Some of those scripts run in a matter of seconds. Others can run in a matter of minutes, depending on the extent to which you use that component. For example, the more items you have in your XDB repository, the longer it takes to upgrade your XML database component. Other things that matter would be things like the size and complexity of the dictionary. And you can measure that kind of at a rough level by just doing a select count star from a JDollar. Now, an empty database might have something like 40 or 50,000 objects in it, depending on the number of components installed. A complex dictionary, like say eBusiness Suite, which has over 50,000 packages in it, lots of dependencies and so on, that might have 2 million objects in OBJDollar. And I've actually encountered some customer databases with over 20 million objects in the database. Because much of what upgrade does is querying, updating, inserting into these dictionary tables. The bigger those tables are, the more it can affect your upgrade performance. So that's just a factor there. It's not about your user data, it's about your dictionary tables. And then finally, there are going to be some cases where version and feature combinations have an interplay that affects your upgrade duration. For example, when you're upgrading from, say, 11.2 to 12.1, you're going to see some repartitioning of your auditing tables. And if you have millions and millions of audit records, which we have seen in some cases, then that repartitioning can be fairly time-consuming. Now, when you run into that kind of thing, what we will do is we will warn you about it in the pre-upgrade or in the auto-upgrade analyze phase. And we will often have fix-ups that are available for you to run before you get to the state of upgrading your database. In other words, you can fix that issue before it occurs by running a script, say, on your production system while it's still up and running. And we make sure those are completely safe when we do things like repartition that auditing table. It's not going to affect your running system, but it also then will not be something that happens during your upgrade downtime. So it keeps your downtime as short as possible. So those are the things that actually affect upgrade performance the most. Of course, other things like your system characteristics will affect it. If you have faster CPUs, your upgrade goes faster. We do use parallelism now, up to 8 parallel threads on your upgrade. So of course, you'd want to take advantage of that. Having enough RAM, very important. Having good system resources just in general, of course, makes everything faster. What we do find, however, is that most production systems are more than capable of running the upgrade at an optimal speed. It's one thing when you're just playing around with it on a laptop or in a VirtualBox VM, for example, on your system that you have on your desktop. But once you get to a system that is being depended on to run production systems, generally your horsepower is going to be fine for that. Now, what does not matter at all for your upgrade is the amount of user data that you have, because during your upgrade, we do not touch your user data. We explicitly exclude actions that are going to affect user data from the upgrade. So this means, for example, that you can upgrade your database while all of your user table spaces are read-only. In fact, that is a nice little fallback mechanism that we talk about when we talk about our fallback techniques that are available for the upgrade. So this means that you could have a 50 gigabyte database with a very complex dictionary that takes longer to upgrade than a 500 terabyte database with a simple schema. Your user data simply doesn't matter to us when it comes to upgrade. Of course, we want to take care of it. We want to make sure it stays valid and all of that, but we're not going to change it, and you don't have to worry about upgrade monkeying around with your user data. So that's why upgrade is different. And I hope that gives you a sense of how we'll have to approach things a little differently when we want to talk about diagnosing the types of issues that you might encounter. But the first thing you want to do is know whether your upgrade succeeded, right? I mean, you don't get a nice clean status code always that says, yes, your upgrade is good, you're ready to go. There might be a little interpretation needed depending on the system, and that's what we're going to talk about next. So the first thing to do is look at the log files that we produce for the upgrade. We do try to produce a very robust set of log files for your database upgrade. So what you'll see is in your logging directory, wherever that is, it's usually where you run the upgrade, or you can use the -L parameter to specify a directory for it. You will find one log file for each process used by the upgrade. So you will always have at least cat upgrade 0.log. That's for the main process that will always be there for an upgrade. And then if you have parallelism, say you have parallel 4, then you'll also have cat upgrade 1, 2, and 3. So a total of 4 log files. One log file for each process used by the upgrade. Cat upgrade 0.log is always going to be the largest by far, and that's because not everything in the upgrade can be run in parallel. So even the things that are run serially are going to show up in cat upgrade 0.log. But we also, to make this easier, we produce this upgrade summary log, and that's been something that we've had for many releases now. So what you want to do is first check your upgrade summary log, because that's the easiest way to get a sense of, did everything work, right? Are your components all valid, for example? Well, the first thing you're going to see is your components in an upgraded state. That status of your components can be anything from invalid, that's bad, of course, upgrading, which means we're in the process of upgrading, but we haven't finished upgrading that component. Upgraded means the upgrade has finished, but we haven't yet recompiled all the invalid objects. And then valid means that we have done our recompilation and we have validated that component. Each component not only has its own upgrade script, but its own validation script that will tell you whether that component has upgraded successfully and everything's clean. So first of all, you want to see upgraded status there. Then you run utlrp and run your post-upgrade fix-ups if there were any recommended by the upgrade. Now, if you have a problem, if your upgrade summary log looks like this, you've got a couple of invalid components, then the first thing you want to do is go look in the registry $error table in the database. We put all of the errors that we encounter during the upgrade into that table to make it easier for you to query it on a time ordering basis, filter it on, using all the query tools and language that's available via SQL query on a table. So the errors will be listed there. And then also you can look in your cat upgrade logs. Personally, I like to start with looking at the registry $error table sorted by timestamp and look at the very first error that I encounter, because generally what will happen in an upgrade is if you encounter one error, that will cascade onto other things. For example, if you are supposed to be creating an object and that object creation fails for some reason, then any alter of that object will fail, any views defined on top of it will fail, and so on. So you really want to start with the first error in chronological order. If you've got components invalid, well, the first thing you want to do is try running UTLRP. Sometimes that will fix those components. Otherwise, you might have to look into the more detailed issues that you found. So depending on the error, you might have different things you need to do. Maybe there was an error because you simply ran out of disk space, whether it's in your flash recovery area for you were using a guaranteed restore point, or even the log file, maybe that didn't work, or maybe you've got a, let's say a table space that didn't have enough room to add more objects to it and auto extend wasn't on. So you might have to fiddle with your disk space or something like that. You may need to reinstall a component. If the component didn't upgrade correctly, maybe it wasn't in a good state in the first place, and there's a way to fix that retrospectively, or you might have to call support. So let's look at an example here. In this case, we are looking at the upgrade log file. Here's the output of the upgrade log file, and it will tell you very explicitly that there were errors found in the log file. It tells you where they are, which of your multiple log files they were in, and at what line number of that file. So that can be very helpful. So in this case, what we found is there's something going on in the XDB, the XML database, the upgrade script. And that error that was found was a table or view does not exist. So in this case, what we would do is we would go to the log file, look at what table or view does not exist, and we may have to perhaps reinstall the XDB component to make sure that it's in good shape before the upgrade. Another thing that we would do is make sure that components are valid. Look in the upgrade summary log. As I mentioned, upgraded status is good. Invalid status is bad. Upgraded will change to valid after you run UTLRP. And in the upgrade summary.log, you might even find more detailed information depending on what the error was. In this case, with that bad XDB component, the XML database component was in such bad shape that we couldn't even get a good summary status from it. So that tells you that there's a real problem with that component. You might be then raising an SR, or as I said, reinstalling the component just to make sure that it's in good shape. If you want to look at a video about this, granted it does not have sound, but there is a little video that we've got on YouTube about looking at your upgrade summary log, your other log files, and kind of delving into this kind of success or failure condition. Now in multi-tenant, you've got another thing that you want to look at, and that is after you upgrade a multi-tenant container database with PDBs in it, you want to make sure that all of the PDBs are able to open successfully. That means open and be unrestricted and be open read write or read only, whichever is defined for that PDB. If you see the PDBs in the mount state, that's an indication that there's a problem that you would then need to look at. So it means these three PDBs in this case, the seed, PDB seed opened in read-only, which is its normal state, so that's fine, but PDB 1, 2, and 3 did not open successfully. So what I do in this case is we can look at the upgrade log, and what we find is, oh, whoops, we'd forgotten to open the PDBs. When we started the CDB up in upgrade mode, we forgot to open all the pluggable databases in upgrade mode as well, and upgrade will only upgrade those PDBs that are open when the upgrade starts. So we tell you about that in our upgrade log. And this is a pretty trivial example, but the main point is after an upgrade, you want to make sure that all your PDBs do open correctly. Okay, so let's see what to do if you do encounter an error. What are the kind of common issues you might encounter, and what are the approaches that we might take to diagnose them? So here you see the list of the most common issues that you might find have caused a problem with your upgrade. And many of them have to do with that garbage in, garbage out principle. If you had invalid components or invalid objects before the database was upgraded, the upgrade may not fix those problems. In fact, those problems may cause the upgrade itself to fail. So if you have an invalid component prior to the upgrade, you will be warned about that by the pre-upgrade script, or now, of course, auto upgrade will warn you about that very explicitly. If you do have invalid components before the upgrade, please, please, please do not ignore that. Even if they are components that you are not using in your application, when we go to upgrade them, if those components are invalid because they don't have access to resources that they need, like there's a table missing, or a package that is invalid because the header is there but the body isn't, or something strange like that, well, that's going to cause the upgrade to fail. So make sure your components are valid. First step would be to run utlrp, and if that does not fix your invalid components before the upgrade, well, then it's probably a good idea to raise an SR with support to figure out, why is this component invalid? Can you determine whether it's in use in the database? Maybe you can remove it, maybe you can't, maybe it needs to be reinstalled. That is the single most common issue that we encounter when people say their upgrade failed, which is admittedly very rare anyway. An upgrade failure is usually caused by an invalid component before the upgrade. The next most common issue we might run into is invalid objects in the sys and system schemas. Now, invalid objects are not always a bad thing for upgrade. I mean, they're never a good thing to have an object that's invalid. That means that the object's not usable because something that it needs is simply not available. Maybe it doesn't have permission to access it. Maybe the underlying table for a view doesn't exist. Whatever it is, there's a problem with that object. And there are some cases where you'll have hundreds of invalid objects in the database, but your application's fine with that. Many enterprise applications like eBusiness Suite, SAP, JD Edwards can run with hundreds of invalid objects because they have so many different modules that may or may not be installed. And then as long as you're not using them, you're fine with invalid objects there. And upgrade's fine with application objects being invalid as well. But you can think of the system and sys schemas as being the upgrade application schema. If there are invalid objects in sys or system, that is almost always going to be a problem for the database upgrade. So we want those fixed before the upgrade. If you want to look at, for a list of invalid objects, look at the DBA invalid objects list or view for the list of objects. You can query it based on the status. And the reason I point you to DBA invalid objects as opposed to DBA objects is that we filter the DBA invalid objects view to look at only the things that we actually care about and not look at all of your application objects that may still be invalid. If you have invalid objects there, you will be warned about that again by auto upgrade, by pre-upgrade, depending on what you're using. Hopefully you're using auto upgrade now. Run utlrp, that will generally fix those invalid objects, but if they are still invalid at that point, that's when you want to raise an SR and determine, is this an important object? Is it just something that DBA left randomly in your system schema 5 years ago before they left the company, and maybe you can delete it? There are lots of cases that can happen here, but you want to make sure that you understand what's going on in your sys and system schemas. Now, sometimes we do run into issues with resources during the upgrade. And I'll tell you, I've seen this, especially if you're upgrading a 12.1 or 11.2 database to 12.2, 18, or 19. We do find that there is an increase in resource utilization, particularly shared pool. So you might want to pay attention to that when you're upgrading. We find that sometimes you need as much as 20% higher shared pool when you're going to 12.2 or 18 or 19. If you're going from 12.201 to 19, you probably won't see that. It's really that 12.2 seems to be the dividing line there. And I don't know whether that has to do with that being the release where we introduce long identifiers, or whether there's other structures in your SGA that are taking more space, but that is something to pay attention to. When you run into resource issues, it's usually something that we would have flagged in the pre-upgrade or the auto upgrade. So please don't ignore the advice from auto upgrade or pre-upgrade where it's telling you to increase memory sizing. If that happens, you do need to take a look at it, but also be aware that our recommendations in those tools are really only based on the minimum requirements for your upgrade. What we can't do is say, yes, well, we know that this particular application is using more than the normal amount of buffer cache, and therefore the buffer cache here has to be higher than the minimum. We just don't have that information about your particular environment. So if, for example, you know that through your testing you're going to need more memory, then that's something that you'll have to take care of. Another issue that we do run into occasionally is a Java issue when you've got the Java mitigation patch installed. Now, this gets into that favorite topic that every DBA loves, and that is the patching of the OJVM component, the Oracle Java Machine, which runs Java in the database. Most DBAs are aware that this has been a patching conundrum for several years, ever since Oracle bought Sun and when we started fixing all these security bugs in your JVM. And the problem is that the JVM patches are not rack rolling and they're not standby first installable. So many customers, instead of patching that JVM regularly and incurring downtime in their database to do so, what they did was they chose to install the Java mitigation patch, which is a patch that turns off the functions in the JVM that were problematic from a security standpoint. Well, the thing is, if you have that Java mitigation patch installed, then the Java upgrade is not going to run properly. So what you need to do is you need to disable the Java mitigation patch before the upgrade and then re-enable it afterwards. If you're doing a manual upgrade, then you have to do that yourself. But the good news is that auto upgrade with our latest autoupgrade.jars, which you can get from My Oracle support, we do that automatically for you. As part of the upgrade, we disable the mitigation patch, run the upgrade, and then afterwards we re-enable that mitigation patch if it is present. That's just something to be aware of, though, if you have that patch installed. And finally, sometimes we do run into pre-existing dictionary corruption in a database. Now, first of all, let me tell you what I mean by dictionary corruption. Dictionary corruption is not the same as, say, disk corruption, which is generally a sector goes bad on disk because it's losing the magnetic properties of the media, or somehow someone put a big magnet too close to your flash memory and it's corrupted it there, or something like that. It's also not the same as memory corruption, which is usually a buffer overflow error because someone's been sloppy in their programming and they've inserted too big a value into a particular buffer. Now, dictionary corruption, simply put, means something in the dictionary that shouldn't be there, or something missing from the dictionary that should be there. It's something's wrong in your data dictionary. And this is most likely to happen if you have a very long-lived database that has been patched and updated over the years or even decades. And this was especially true back in the days of, say, 8i, 9i patching, where it was very possible that you could apply a patch as the wrong user. So this was before the days of data patch, let alone SQL patch. And what could happen, for example, is you get a patch and you log in as sysdba and it applies a bunch of things into your database, and then, whoops, turns out you were supposed to be logged in as system, but not as sysdba, and then you rerun the patch. And in that case, for example, you could have duplicate objects in the sys and system schema. There are other things like that that could occur, and many things that we've found in customer databases over the many, many years that have occurred, and we don't always know why or when they occurred. We just know that they're there and that there's something we can fix. So I reference a bug, for example, that was caused by such a dictionary corruption. This happens to be a bug that is accessible in My Oracle support. That's why I picked that one out. And what happened there was, during an upgrade, you see they got an Aura 600, pretty serious error. And it was because there was a row missing from the dependency table in their database. Now, why was that row missing from the dependency table? Nobody knows. By the time we encountered this, it's impossible to diagnose, unearth the cause. However, we do have a health check script that will find these kind of things. And that's what you see at the bottom here. hcheck.sql is a health check script that is very lightweight. You can run it on any system, and it looks for these dictionary corruptions and gives you references for how to fix them. So here's an example of the output on an artificially created situation that I put into our hands-on lab environment. Just running this health check script, which by the way, takes less than a second to run on your typical dictionary. It's very, very lightweight. It's just a bunch of read-only queries, won't modify anything, so don't worry about that. So I ran this and it comes up with this message saying, hold it, there's something in your source dollar table, in other words, your PL/SQL packages and procedures, where the object number for that particular piece of PL/SQL source is not listed in the OBJ dollar table, and OBJ dollar should have every object in the entire database there. So clearly there's something wrong here. Now, is it a matter of someone trying to drop a package and somehow that drop did not complete? Or maybe someone tried to add a package and somehow adding it didn't complete and add an entry to OBJ dollar. I don't know. But at this point, the important thing is that we've detected this condition and we've given you a reference to a MOS note that you can go to help remedy the situation in your database. So that's what hcheck.sql will do. I recommend running this anytime you're going to upgrade a database. And in fact, I would run it at least once a year on any production database, just to make sure that you're not getting these little things creeping into your dictionary that could turn into big things down the line. Another thing that we really recommend is to run OraCheck. OraCheck is the outgrowth of RackCheck, and OraCheck will check your entire Oracle stack. Now, what that stack is going to vary depending on whether you've got the database, real application clusters with grid infrastructure, maybe an engineered system such as an Exadata. So we've got Exacheck there for Exadata environments. But the important thing is that it also has a pre-upgrade mode in which you can run it. And what that will do is check your entire system for the health of that system regarding the possibility of upgrading to a new release. So you want to go to that note, and that will help you download that right OraCheck for you. And that will depend on, are you in the Exadata environment, for example, or not. Here's a sample of the output running this. I think this was on a 12.2 database. And it gives you a sense of what I mean by looking at the entire Oracle stack. So the first thing is the label security in database vault prior to upgrading. That's actually a pre-upgrade script warning saying that there is a script that you can run to update your audit table if you have label security involved, because in this particular version, source and target version upgrade, what we have to do is move your audit records from system.odd$ to sys.odd$. And you can do that before the upgrade and save yourself some downtime. So it's giving you a warning about that. You can see some other things that are outside the database. Your TNS admin environment variable is set, and maybe we don't recommend that in this case. We give you some information about operating system packages that are going to need to be updated or that should be updated or installed in this case. And then there are other things like system resources, your Linux swap environment. So it's everything from database pre-upgrade to system resources to operating system and a whole bunch more that OraCheck will tell you about. So if you look at that output and act on those, you're going to be much more likely to have that good, successful, smooth upgrade that everybody wants. Okay, so let's say you're not running into an error in your upgrade, but you're getting a performance issue in your upgrade. In other words, the upgrade itself is taking much longer than it should and much longer than you have available. What can you do about that, and how can you diagnose those issues? Well, the first thing you want to do is determine whether a performance issue is a hang or whether everything's just running really slow. And to be honest, this really comes up most often when people are using DBUA, because DBUA has that progress bar, which is, let's put it kindly, very imprecise. And it will lurch along, and then it gets to 68% done, and it sits there for some amount of time, and you're wondering, is it making progress here or not? Well, what you can do at that point is just simply go to, say, top in your Linux environment and see what's going on. You see here the two cases in black and white. And what we do at the very highest level is we look and say, okay, what is using the system resources at this time? On the left in black, what you see is the Oracle process is front and center on the CPU. It's using your CPU time. That means it's trying to do work. It may not be doing it efficiently, or it may have a lot of work to do, but at least it's doing something, because the Oracle process is in the foreground. But on the right, what do we see here? We see background processes. In this case, the archive logger is taking all of the time, and the Oracle process, you see it's not down until like midway down the screen there, using 0.3% of the CPU. That means this is thrashing on your background processes. Something is wrong here, and that's a hang. And you're going to diagnose these two cases very differently. So first, what do we do about a hang? Well, on a hang, it's generally due to one of two situations. Either you've got resource exhaustion, you're out of memory, you're out of disk space, something like that, or you've got an application deadlock. And in those two cases, if you've got a resource issue, that is actually the easiest thing to diagnose. If you've got a deadlock, that should never happen in the upgrade because we have exclusive access to the database. So if you've got a deadlock, then open an SR immediately. On the other hand, if you've got slow performance, it's the typical causes there, right? A poor query plan, maybe it's just a really complicated dictionary so that the queries take a long time to run, or maybe, again, you're low on resources and that's making everything less efficient. So that, what we say here is you would diagnose it like any other performance issue, but remember here you don't have AWR available. You don't have all the tools you would normally have available. So we'll look a little bit at what you can use to diagnose a performance issue, especially if you can reproduce that issue outside of upgrade mode. So first of all, you want to look at the alert log. And again, there's a little bit of a video here without sound, but it's only a couple minutes about looking at the alert log and seeing what's inside it. And here's something that would be typical of that. In this case, the alert log was spitting out messages saying, hold it, your DB recovery file desk size is 100% used, 0 bytes available. So what does that mean? This means in this case, I had said I have a guaranteed restore point for my upgrade, which allows me to flash back to the previous version if my upgrade doesn't succeed. So that's a great fallback strategy, but you do have to make sure you have enough space in your flash recovery area to maintain that guaranteed restore point. And in this case, I had a ridiculously small flash recovery area of only 100 meg, and it quickly filled up while I was doing the upgrade. And that means, because I have a guaranteed restore point, that the upgrade will stall at that point. So all I have to do here is go into another window, say, connect to the database, alter database, set DB recovery file desk size to a larger number, and that will free up my system and address the hang. That's a trivial case, but the idea is you're going to look at the alert log and address whatever is showing up there. Another thing you can do, though, is you could look at a hang analyze. Again, go to another window, connect to the database in SQL+. It is, after all, open in upgrade mode, so you could connect to it, and you could run or a debug hang analyze. And what that will do is it will look at the various processes that are running from Oracle and figure out which ones are hung and likely why. And this is from that very same case. You see here it's saying control file, parallel write, block range reuse checkpoint, flashback log switch. Again, it's a flash recovery area is full. I'm not able to go to a new log file because I can't create a new log file. So in some cases, the alert log is going to be much easier to interpret. In other cases, you might want to use hang analyze because there's a lot more detail there, including things like that NQ event that is very specific. Now, if you are instead on a case where you have just slow performance, then what you have to figure out is it just one acute problem, maybe a query gone haywire, or is it a systemic problem that you're dealing with? And again, there are some indicators there. If I look at an upgrade, and these are two cases of somebody saying, or me creating a case of, gosh, this upgrade is really slow. If you look at one versus the other, On the left side, what you see is that there's one component, the Java virtual machine, that took over 10 hours to upgrade. That's clearly an acute issue because everything else there, that's moving along pretty well. 21 seconds for your OLAP upgrade, 13 seconds for label security, a minute for text. That's not bad. But 10 hours, 53 minutes overall, of course, is terrible. So in this case, we would look at that specifically what's going on in the JVM upgrade. On the other hand, on the other side, we see a more pervasive problem. If you look at the times of all the components of our 5-hour upgrade, every one of them, except for Java, is multiples longer than what it was in the 10-hour upgrade, right? Which is kind of counterintuitive. Look at multimedia on the right, 12 minutes, 54 seconds. That's ridiculously long for multimedia. Minute and 45 seconds, much more reasonable on the left. So a pervasive system problem, it could be something like I/O performance. If your database is on a NAS device, maybe you've got your network swamped. Maybe you have just not nearly enough memory and you're thrashing on swap or something like that. But they're going to be very different cases. So if you have your slow performance, the first thing to look at is going to be statistics. That's the #1 cause of long-running upgrades is bad statistics. And when we say statistics, we're not talking about your table and index statistics on your user tables, because remember, we're not going to touch those. We're talking about the ones that we use during the upgrade, which are dictionary statistics, fixed object statistics especially. So we are working in the data dictionary on those dictionary tables and the views that are built on them. So we need those dictionary tables, the system views, the fixed views, which are based on fixed objects, fixed tables. We need them to have good stats. And we will recommend gathering stats if we think that they are stale. If you're in the pre-upgrade script, we will recommend this to you. If we run auto upgrade, we will gather stats automatically if they are more than 1 week old. So you can see the query that we can use to say when was the last time you gathered object stats or fixed object stats or dictionary stats. You could do this yourself. Auto upgrade will take care of this for you, but it's a good idea to have good dictionary stats all the time because they will affect other operations, like any data pump export or import is heavily affected by your dictionary stats. That's just one example. So if you want some examples, some other things that may help, actually, let me get to this first. On top of dictionary and fixed object stats, we have found cases where just gathering stats on the entire sys schema will help. Not always, but sometimes it will. And then specifically these cluster indexes, which are listed here. Now, the reason for these cluster indexes being important is that they're on some of these very important tables like obj dollar, user dollar. And what I found a couple of years ago that there was a bug under which cluster indexes were not having their stats gathered when you gather dictionary stats, or even if you gather schema stats on sys, or even if you gather stats explicitly on the tables where those indexes are. So a couple of things you can do. First is you can run these statements that you see here that gather index stats on each of those cluster indexes. Or you could use auto upgrade because it'll do this for you. And gathering those cluster index stats is pretty quick because it's just some very specific indexes on very specific tables. The other thing is that you might want to download the patch for bug 292.86.469. That's available for every version that is under support now, 11.2 all the way up to 19C, and that will cause these stats to be maintained automatically. And that will really help when you're doing your upgrades or any data pump exports and imports. So let's look at the effect that this can have on a trivial upgrade first. If I take the empty database with just a couple of components that we use for our hands-on labs, it's just a very small, uncomplicated dictionary, and I make all the stats in it stale, it takes about 16 minutes to upgrade. If I gather dictionary and fixed object stats, I'm saving about 11% of that, and then gathering those schema and cluster index stats, another 3.5%. So I'm saving 14% of my downtime overall for gathering stats, which is always a good thing to do anyway. And 14% may not seem like a lot when I've got a very fast database upgrade of, say, 16 minutes. But if you've got a database that would normally take an hour to upgrade because it's got a complicated dictionary, think about what 14% of that hour is. Now you're dealing with, about 10 minutes less downtime, which could be very important in some situations. And if you want the other extreme there, let's look at that database that took over 10 hours to upgrade. The reason it took that long was I had gotten rid of the stats there, and by gathering good stats, there was one query that improved so much it saved 93% of the upgrade time. So I'll show you that query in a second, but this gives you a sense of what the difference can be on good versus bad stats on a complicated dictionary. In that case, it was something in the JVM where there was a lot of Java in use. And if we look at that query, there was that one query in upgrading the Java component that took almost 10 hours to run. And it's a simple query. This is the whole query plan, something that any of us can probably understand. We could kind of draw out, okay, here's what we're accessing in which order and how we're joining them together and so on. But as a DBA, would you know that the difference between an index full scan and an index range scan in a few cases is going to be the difference between 2 seconds and 10 hours to run that query? Probably not. So having those stats in place is going to be very important. Now, sometimes it's not stats, and there are other things that can cause problems. Maybe you have a really complicated data dictionary. I had the one user database, for example, with over 20 million objects. Well, the fact is, when we're modifying tables with 20 million rows in them, it takes longer than tables with 50,000 rows in them. There's nothing we can do to get around that. So if the more complex your dictionary, yes, the longer it will run. But there are cases where we may have either unforeseen use cases or bugs that affect performance, and we try to address those when we can. And I've given you an example here, this file catuposb.sql. This is a SQL file that's part of your upgrade, and you can actually look inside this file in your RDBMS admin directory, and you will see at various points in there comments about changes that were made for each of these cases. The extremely complex data dictionary, there was a case where we changed the way a particular query was coded to be more efficient on really, really big data dictionaries. Unforeseen use cases, well, what had happened was there was a bug where there was a customer who had certain init parameters set to non-default values. In fact, they were optimizer parameters, and that was causing problems in this file. So when we run this, we now set those parameters at a session level. And then there were some bugs. There was a bug where, well, we considered it a bug, where what happened was we were updating one of the dictionary tables, and then when we queried it later, our update had caused the stats on that table to go stale. So in between the update and querying later, we gather stats. So we fixed that. So that's just an example of the kind of things that can happen, and we do address those whenever we find them. So now let's talk about some things that you can use to diagnose problems automatically. One of the things that you might want to look at is ADDM, your Automatic Database Diagnostics and Monitoring, which is part of the Diagnostics pack. So if you have AWR, you have Diagnostics and Tuning, you can use this. And the most common place you'll see this is at the end of an AWR report. It amazes me how many people never get to this point in their AWR reports, even if they're diagnosing a problem. At the end, there are findings and recommendations. And this is an example of one, where on this system, basically it's telling you you're CPU bound. So you could be looking at what's the top SQL, what are the wait events and all this, and you're saying, oh, yeah, we're using CPU, that's what we want, because everybody knows, and I'll put that in kind of sarcastic air quotes, everybody knows that as long as you're using CPU, then you're getting work done and it's efficient. But that's not always the case, right? In this case, you are CPU bound. So you're either going to need that tells you, don't go looking at your IO as the culprit, what you want to do is either look at who's consuming the CPU, make that more efficient, or maybe you just need a bigger system, because sometimes you just need a bigger system for the workload which is expanded over time. So look at those findings and recommendations. I'm going to skip over the operating system tools to find bottlenecks because I'll be honest, I'm no expert on them. Most of you are. So when you download the slides for this presentation, you will find kind of an overview of the various tools that are in there at the operating system level, whether you're looking at NetStat or other, the memory usage and so on. I do want to look at some Oracle provided diagnostic tools as the last part of this talk. So first is that we do have references and my Oracle support, things like how to diagnose it hangs. So use that note as a reference if you're running into a hang, whether it's your database in general or in the upgrade itself. For tools, individual tools, we have HangFG that will kind of automate not just looking at your hang, but producing the right dump files to analyze it further. So we've got a user guide for that tool. ProcWatcher is looking at your background processes, both for the database and for grid infrastructure. So that's a useful tool as well to see what each process is doing. If you know what the problem process is, you can delve into it further. And then OraTop, sort of like Top, except focused on, of course, your Oracle processes, because that will help you weed out some of the noise on your system, which may not be interesting when you're looking at diagnosing a problem. And the main thing to mention here is that we've taken all of these tools and more and incorporated them into what is now called the Autonomous Health Framework. You might get a hint from the name of this that this is something we've pulled together and refined over the couple of years now that Autonomous Database has been available, and we continue to refine this. It includes TFA, which is our trace file analyzer, or a check, an ExaCheck, depending on which platform you're on. And I talked about OraCheck earlier. You saw some examples of that, but it has so much more. Not just the ProcWatcher and OraTop that I already mentioned, but if you look at what is in there, when you go to the note to download it, you've got so much in there about debugging and getting history and summaries and very specific Unix type utilities to do listing and editing and all this good stuff. So this Autonomous Health Framework is a really good tool for any DBA who wants to diagnose issues on their system. And of course, that applies to upgrade issues as well. The last thing I want to mention, very specific to upgrade, is that we've thought about this whole situation of needing to diagnose issues when we built Auto Upgrade. We wanted to make it as easy as possible for you to interact with support. So we built in this option in Auto Upgrade, the -zip option, where if you ran into a problem with your Auto Upgrade, say -zip, and what it will do is it'll go into your config file, find all of the log directories for any upgrades that were being run, because remember, Auto Upgrade can upgrade multiple databases at a time with one command. It'll zip all the log files that we need together in one place, and then you can upload that to MOS. Now, what we don't do is get the alert log for each one of those databases, because frankly, we may not be able to. If your database is down, we may not be able to go find the diagnostic desk for it or something like that. So you would want to get the alert logs as well, but just the process of collecting those multiple log files for each database. Remember, you could have multiple upgrade logs, you can have the pre-upgrade, the post-upgrade, and so on. Do it for multiple databases, and then also for the auto upgrade session, all in one tidy zip file, which you can put into your SR if you have a problem. Now, all that said, your upgrades almost always go fine. So if you want to follow on and get slides about this or anything else related to database upgrade, you want to go to Mike Dietrich's upgrade blog, MikeDietrichDE.com. The DE is for Deutschland. That's our 2-letter code in Oracle for Germany. Mike works for me out of the Munich office, so you're probably familiar with his work. He's well known around the world as the technical expert on database upgrades. Normally at this point, I would ask for questions. Unfortunately, this being a recorded session, I'm not going to be able to do that. So what I will do is just say thank you for attending. I hope you found this useful. And if you do have any questions or interest in database upgrades, go to that upgrade blog, and that's going to be a great source of information and a way to interact through the comments section. So thanks again, and I hope you have a good rest of the Groundbreakers tour.